Hello, welcome to this channel. My name is Enoch. Today we will continue our series on Python. We will continue our strategy of learning Python, with projects. And today we will be doing Cipher encryption. And in this encryption, we need to expand our knowledge about some things about Python. We will learn functions with position and keyword argument, and we will also learn try and except function before we can be able to do the project properly. So let's just get right to it. Now we look into function in my last two videos, and we know that when we want to define function, you use your def word followed by the name of the function. Let me say introduce, def introduce, and I can say name, I can say age, and I can say country, right? And you close it, you give your colon, and you give I live in okay. So this is a function. Now we know that this name, age, and country are just parameters. They are parameters when you have not given the value. When you define it like this, they are just parameters. But you can but by the time you have your value, then they become the argument. So the value is the argument. These placeholders are just the parameters, and I will put the argument when I'm calling the function, right? When I'm calling the function, say I call the function John, and John's age is let's give him 56, and let's say country is USA. Now the way I'm calling the function like this, this is a keyword argument. You can move this country to this front like this, with this country there like this, with colon there like this, and you'll be fine. You can move name John, you can move it to the back, you can move it to the middle, and you'll be fine, But if all this name is not there, PyCharm is just defining it like that for me. I probably want to remove this name, age, and this country first, and just give the argument alone so that you guys can see it. So when these placeholders are not there, they will just be position arguments. Python will take them as, okay, this is standing in the place of name, so that is for name. This is standing in the position of age, that is for age. And this USA is standing in the position of country, so that is for country. So it will take them as position argument. But once you give their parameters name ahead in frame as previous like this, then they become a keyword argument. So it's just so you can move them around the way they are like this, and you'll be fine. You can call this function, and this function will run normally. Okay, so that is just about function with position and keyword argument. They are just no more than that. Let's look at try and except function. Now, try and except function is just a way to undo error gracefully. It prevents program from crashing when errors occur. All right, I can say def, and I can say divide, and I can say a comma b, and so I can say try, and I can say okay, I can say try, and I can say result equals to a divided by b, and I can say print result like that, print result. And I can go ahead and say except say zero division error, and I will say print you can't divide by 0, right? And I can also add another one, except I can say value error, and you can bring it down like this, and you can say error please provide numeric value, or number only, like that, numeric value or number only. Let me make it number only. All right, number only, like that. All right, so now if somebody say, if we'll say divide, and we'll say divide 10 over 2, 10 comma 2, and I say divide, and I say 10 comma 0, 10 comma 0, and I say divide, and we'll say 10 comma a, 10 comma a, like that. And if you run this, you will see what you will get. Now if you run this one will run properly. Let me comment out this one too, and let's run this first one, and this one will run properly. You will see that's 5.0. but if we comment this one out and we run this one, you will see 10, and 10 divided by 0, you will see that this one will raise an error. You can't divide by 0. I can put error here, error, and I can say you can't divide by 0. All right, so try and accept is basically used to undo errors gratefully. They prevent your program from crashing, when errors occur. So instead for these to raise an error, from Python directly, you can give your own error, and your program will not raise a direct error from Python, and you can put this in a while loop so that it will just restart the program again, and it will run it again and allow you to give another input. So that's just an example. Now let's go straight to our project. Our project today is Cipher Encryption, like I said, and let's just go and read a little bit about our project. Let's go and read a little bit about our project. I have just check it out, like here on Google. Cipher. This the Cipher cipher is a simple substitution cipher in which each letter in the original message is shifted by a fixed number of positions down the alphabet. It's named after Julius Caesar, who used it for military communication. So it encrypts by shifting letters forward, such as A becoming D, with a shift of 3. Decryption involves shifting the letters back the same amount. For example, with a shift of 3, LO will become KHOOR, like that, and KHOOR will decrypt back to LO, So that's just that's just about that. And if you go, you can read about it from Wikipedia. In cryptography, Cipher cipher, also known as Caesar's cipher, the shift cipher, Caesar's code, or Caesar shift, it's one of the simplest and most widely known encryption techniques. So it just basically shift the alphabet to something else, it just shift it forward, by the number that you give. So that's what we want to do today. I've tried to break down the project down in this place, so that the way to solve a project easily is to break it down into smaller bits, and you can be able to easily solve it, small like that. So I try. So the first thing you do is to first understand the problem. So we know that this problem is a simple encryption technique where each letter in a message is shifted by a fixed number, in the alphabet. So with a shift of 3, A will become D, B will become E, X will become A. That's X, Y, X, Y, Z. Y will become B, Z will become C. Just like that. So they will be shifted forward. It will shift forward by the shift number that you give. That's just what we want to do. So I try to break it down myself so that we don't waste a lot of time. So instead of writing big code, you can divide it into smaller tasks, right? The first thing I want to do is I want to look at, okay, what input does with this project accept? Encode or decode? Yes, we want to check if we want to encode, because there are two major operations. Do we want to encode or do we want to decode? Another input that it will accept is test. Another input it will accept is test. Whatever test you want to decode, you want to decode or encode. Another thing it will accept is shift number. I know that already. Shift number test, encode and decode. So automatically I know that I'll be using a def function that will be I will probably have two functions, encrypt and decrypt, and I will be giving it three values. One will be test, one will be before test, maybe I will have, let's say test, and I will have shift number, and that's the number of time, the number that the alphabet will shift by, and I will also have encode or decode, like that. I will have encode or decode. I can call this mode. Instead of encode or decode, like that. I can call this mode. So does that mean that we also need to create another function in decrypt? Does that mean we need another function in decrypt? Do we still need to do decrypt? So when people are trying to send a message, they will be using letters, numbers, maybe special characters, so I know that this will involve lowercase letters and uppercase letter. I know this will probably involve digits. This will involve, special characters, in symbols. And I thought of the output that we will give. Okay, what output is this program going to need? There is going to be a final output, which is maybe the encrypted value or the decrypted value. So I'll probably be giving a result equals to, maybe empty string or empty list, like this, or list, something like that. One of the two is what I will use. So so you're going to need lowercase alphabet, uppercase alphabet, digit, symbols, like that. And from there I know that I will need the string module. We need the string module, so I will import the string module, so I don't have to start typing alphabet one after the other, and I can loop through the alphabet that I will import. So I say I have to loop through each character in the test, in whatever test is given, and I will check if the character is a letter or is a digit or is punctuation. The letter can be uppercase or lowercase. That's one thing that we also have to pay attention to. Then we look at the shift. We shift the letter by the shift number. Then we convert the letter, or the number, to the ASCII, to the alphabet value, or to the ASCII value, or the alphabet index. You understand when I'm coding it now. So we have to get the index of the shift. So when we add the shift, we first get the index of the character first. Then we'll now add the shift number, which is going to help us to get the new index that we are going to use to get the value of that particular index. Then we apply the shift, we wrap around it. So we also think of, after adding the shift, what if the value goes beyond z? How are we going to do it? Then you may be thinking of, how many value is in A to Z? How many value is in A to C? Then we know that is 26. That is 26. Are we going to subtract by 26 so that in case there is a problem, no, subtraction will not work. What we will use is modulus. Let me give you an example of why modulus is the perfect thing to use. If you go to if you type this Python module, and if I say 9 modulo 26, you will see that it will give me 9. It will give me 9. If the value is above the denominator, then it will give you the value back. But if I say 35 modulo 26, you see it will give me the leftover. Divide it by, it will get 1, then it will remainder of 9. Oh, I don't want it to remain 9. Let me say 49 modulo 26. Then you have 23. So modulo is the perfect thing. So it will divide and give you the remainder. And if the value is not enough, then it will give you the value back. So modulo is the perfect thing to use in this case, instead of using subtraction. So we'll convert back to letter, symbol, or digit. We'll build the encryption string. That's the result, final result. Are we going to use two functions? Can the two functions be written as one single function? Don't repeat yourself. Because if you look at it, the only thing that is going to be different is during encryption and decryption is the fact that we are subtracting the shift number, we are deducting the shift number. So another thing I also thought about, can the encryption restart? Can the program restart, till the user tell it to end, something like that. So these are I can keep breaking it down as much as possible, and I will keep being able to figure out gradually what I'm supposed to do and how I'm supposed to type, write this program. So let's start writing it gradually. The first thing I know I need is to import string, right? Import string, and I will say that string dot ASCII dot underscore lowercase, because I want to separate lowercase and uppercase. Then I have the uppercase, then I have the digit and the punctuation, like that. So I've just brought in the lowercase, uppercase, digit, and punctuation, like that. So from there, now what next? What do I want to do? I probably want to just start the function definition straight. I can say dev, then I can, so the first thing I want to do is to do the encrypt. So let's say we have a test, then we have a shift number, then we have a mode, right? A mode will be encode or decode, right? Then we will don't forget we will need the final result, which I will just put. You can use string, you can use list, you can use list as it works for you. If you use list, you will use append to just append it into the list. If you use string, that you will just use plus equal to just add it to your string. So that's that, and let's just loop through the test. I can say for character in test, and the first thing I want to check is if okay, let me make this one, sorry, let me bring this one back, and let me call this one lower. Lower equals to, then I can call this one upper equals to, then I can call this one digits, and I can say digit equals to, then I can call this one symbols, and I can say symbols equal to. All right, so I can say this in letter, and I can say if char is in letter, is in lower, then I can say then the next thing I want to check is then I can say new position, equals to then I can say lower dot index of char. Now I'm trying to get the position, the index of this character in this lowercase alphabet. That's what I'm trying to do. You know, this lower is this lowercase alphabet, so I'm trying to get the index of this character in this lower. That's why I'm calling this new position. And I can say final position equals to new position plus shift, and this new position plus shift number, I will put this in parentheses, and I will do a modulo of length of lower, like this, length of lower. So this will be length of the alphabet. So if I don't want to add code it, you know, so that I can be able to use it for digit, for punctuation, like that too. So so that's that. Final. So this is going to give us the index of the shift number. We have added the shift number to the new position. So if this one was 3, if this one is 3, and we add the shift number, if the shift number is let's say 8 plus 3 will become 11. And if we divide by this length, it will still give us 11, you know, until it's higher than the length of the alphabet, you know. And I can simply append it into my result, you know. So something like that. And now I want to check for upper, so I will just say elif char is in upper, like that. Then I want to just copy this down there. Then I will change this one to upper. I'll change this one to upper. I will change this place to upper, you know, to upper, and I will change this place to upper, you know, upper, like that. So I'm checking. So in case it's an uppercase letter, in case it's an uppercase letter, then it will run through this place. It will get the index in the upper. Then it will get the index after it had the shift to divide by the length of upper. Then it will add it to our final value there. You know, I hope you understand what I'm doing. If you don't understand, that means you probably need to go to some of my earlier videos and get some of these logic very well. So we are checking for digit, and the same thing we are going to do to digit. You know, check this one to digit, change this one to digit, change this place to digit, digit. You know, probably there's a way we can write this without repeating it like this, but you know, because of this elif, you know, which I just need to put it like this. So there is so that's just that. Let's move on from that. So we've checked digit, we've checked upper, lower. So the next thing to check is the symbol. Elif char is in symbols. Then we'll change this one to symbols. Symbols, and we also change this one to symbols, and we also change this place to symbols. Now we have addressed lower, upper, digit, and we have addressed lowercase alphabet, uppercase alphabet, digit, and special characters, you know, like heart and so on and so forth. So what if there is any other thing that is added that we've not had, that we've not all these cases have not covered? Then we will say just else, and we will append the character into our result. You know, just append character into our result like that. So no value will be lost. No value will be lost like that, and we can simply return, or let me just use the word print so that I don't confuse you too much. For now, I can say let's use f string, and I can say encrypted test. No, that's not what I want to say. The mode is the mode. Then I'll put D. The mode will be encode or decode. The mode, the encoded or decoded test. test is this. So this will join the result into a single string, like this. So that's that, and this will print it out for us, and we can simply call it anytime we want. Let's just test what we have written already. So I can say encrypt, and let's just give the first thing. I can say, what's our test? Let's say our test is mountain, string of mountain. Let's say mountain, and the shift number, let's say the shift number is 9, and let's say we want to encode, right? Let's just leave it like that. Mode is encode. So let me see, this mode is encode like that, and we should be fine. So we can give it like this, encrypt like this, mountain 9, and mode is encode. And if you run it like this, you will see that this is what you get. All right, this is what the encoded test is, this. All right, and you can decide to change this one to, let me say, at 1 2 3 4 5, and let's see what this gives us. And let's run this, and you can see our code is working. So let's go and do the decrypt part. So for the decrypt part, the only difference is just the negative part of it. The decrypt is just when we add the shift part of it. So if we turn this one to negative, then you will see that this one becomes decrypt. If we change this to negative and we change this to negative, then it becomes decrypt. Then let's change this one to, then so let's copy this one, let's copy this, and let's try to get our value back, and let's go into our into this place, and let's call this one decode. Let's call this decode, and if you run this, you will see that you get your actual value back. So the difference is just the plus and minus. All right, the difference is just the plus and minus. So I've been thinking about it. Do we have to just copy this and write another function, and that will be a lot of repetition, just because of the negative. But I figured out that we can do something like this. We can do this. Let's move this one down. I can say if mode is equal to decode, then the shift will be equal to the shift number, will be equal to minus shift number. The shift number will be equal to minus shift number. So if our mode is decode, then the shift number will now be equal to, we just negate it, we just negate it. So if you remember in our mathematics, if you multiply negative by positive, then it becomes negative, right? Negative by positive becomes negative. So if you do this, you will see that this works for decode, and this works for encode and decode. If you test it out, you will see that this will work for this. You run this again, you see that, you can see that's the value. And if you go and change it again, and say mountain at 1 2 3 4 5, and you say this one is decode, this one is encode, if you run this one, you will see that, you can see that. So we get our encode correct. And if you change this one to decode, and you copy this, and go and put it there, you will see that it works in the same way. If you run it this like this, and you will see that, you can see that we get our value back. So that's a perfect code that is working for this. So we don't need to we don't need to go and write another encrypt function. So I will only change this decrypt function. So I will only change this one to Cipher. So so it will work for both encode and decode. And this one I have to change this calling to Cipher 2 if I want to use it, you know. So sorry, this one is A, not E. A, not E. So that should be good now. All right, now the next thing I will want to do is I will want to now allow the user to give their test, to give their shift number, and to decide if they want to encode or decode. All right. So let's just go up here and let's say mode. Then you write your input. Now you know that's the input we want. Type encode to encrypt or decode to decrypt, you know, something like that. And we want to no, we don't need to change this, so I can just put a strip here alone, so that if there is any space, I don't need a lower, so that if there is any space it will be removed, you know, to be removed. So let's leave it like that. And the next one is test. Type the test to encrypt or decrypt, to encrypt or decrypt. Type the test to encrypt or decrypt, right? No, this one we should convert this one to string. So the shift number, type the shift number. So this one I want to convert this one to integer, but I'm gonna leave it like this for now. Let's leave it like this for now. Now now we want the user to be able to do this, and from there we will now call the function. So it says Caesar, then that shift and mode like this. And if you run this program, you say type encode. So let us put integer like this. Let us encode this with integer like this. Let's change this shift number to integer, and let's just call this function like this. Let's try and call this function like this, and let's see what we get. You have encode, type the test to then I say mountain at 1 2 3 4 5, and then shift number I say 15, and said the encoded test is this. The encoded test, you know, the encoded test is this. All right. And if I copy this, and I say and I run it again, let's run it again. Type encode to encrypt or decode, and I say decode, and I say test, and I give this test like this, and I use 15. So let me use 15 again, and I say the decoded test is mounting. So you see I'm getting back the exact, you know, the exact value that I gave it earlier. So the code is working properly, is working as it's supposed to work. So we give our mode, we give our test, we give our shift number, and we call the function. All right. Now if the user use something else apart from encode and decode, what happens? So for that, I will want to wrap this up in a while loop. I can wrap this in a while loop. While true, I can make this one true, and I will simply move this. I will simply move this forward, and I will say if mode equals to encode or mode equals to decode, then we'll break, right? We'll break from the loop. Else, then what happened? Print invalid input, then it will go again. Invalid input, then it will go again. So this is the first thing. Then we want to get a test. So the test can be whatever the user wants it to be. So let's check the shift number. Let's check the shift number. For this shift number, I actually want to for this shift number, I want to remove this integer from it. In case the user give anything that is not an integer, then what happens? If the person gives something that is not an integer, then what happens? Then I will want to put a while true here, while loop here. So so 1 2 3 4. Then I will want to use try shift is integer of shift. Then if this works, then that means it's good. Then we will break. Then then we will say except value error, and I will print invalid input, or I will say give a number, please. Type a number, please. Type a number, please. All right, type a number, please, and we can leave it like that. So while true shift number will be this. Try shift number equals to integer. So this function, this integer function, is just, we are just trying to check if this shift number is an integer. So if it is not an integer, then it will raise an error. Type a number, please. So that's that. So that our program will not break. If the person go and type something else that is not an integer, the program will break at that point. So that's why I'm capturing this in this while loop. All right. Now I want the program to continue to repeat itself until the user says, okay, it's no more doing any encryption or decryption. So I can wrap this one in a while loop again, and I will shift this one forward. All right, so all this will be in a while loop like this, and we will. So restart equals to input. Type yes to restart or no to end. Then I will say if restart is yes, then I will print the program is restarting. It's restarting, and else I will say print goodbye, and we will simply break from the loop. We'll simply break from the loop. So that's that. Restart equals to this. If restart is yes, print the program is restarting, else print goodbye, and we'll break from the loop. So this is let's check it from top down like this. So we import string, and we use string to bring in lowercase alphabet, uppercase alphabet, then digit, punctuation. Then we define the Caesar. We use test, shift number, and mode. And if you want, you can say test is string. You can say test is string. And if you want, you can say shift is integer. So and if you want, you can say this is also string. If you want, you can do it like that. And we use this one to just catch the decode negation. So if mode is equal to decode, then shift number will become negative shift, so that we don't keep repeating ourselves again and again. So result equals to empty list. If character in test, for character in test, then we check if the character is in lower. So we do for lower. So we check the index of the character in the lower. We say new position equals to lower dot index of character. Then we find a new position, the index of. Then we add the shift number to the new position, and we divide it by the length of the alpha A to Z. This will be 26, right? So we'll append it into result, right? Lower dot final position. You understand that? And we do the same for upper, and we did the same for digit. We did the same for symbol, right? You do the same for in symbol. So if the character is not in any of the four, then we just append it back into the result, so that we can verify. No value will be lost. All right, so no character will be lost. So that's that. And we print the encoded or the decoded. This mode is encode or decode. So there is a D there. So encoded or decoded test is this, and we use this join function to just change this list back to change it to a string. And we write this while true, then we'll give the mode, type encode to encrypt, and we'll loop through it like that. And so if mode is encode or mode is decode, then it will break out of this first loop. This is a nested while loop. So the first one, it will break out of it once mode is encode or decode, else to print invalid input and it will run again. Type encode, like that, so that's that. And it will move to test. Test is not part of this first while loop, right? To move to test, it will check, it will ask for test input, then it will come to shift number and it will loop through the shift number. Then you are allowed to give the shift number, then it will check if the shift number is an integer. If it's an integer, then it breaks. If it's not an integer, then it raises a value error, so that the program will not give error. To just loop back and ask you type the shift number, and once all the input that we need is ready, then we call the function here. All right, we call the function, and after the function runs, then we come here to check if type yes to restart or no to end. So if restart equals to yes, then the program is restarting and it will run again. If whatever else is given, if it's no or something else, then it's just print goodbye and break. All right, so let's check our program and see if what we have done works. All right, type encode to encrypt or decode to decrypt. Then I will say encode and type the test that we want to give, and I will just give something a little bit complex. November, and I will make this one small letter. I will say at 987, right? November at 987. All right, so this is what we want to. So you can see all the uppercase letter and lowercase letter, right? And you can see at 987. Let's see what happens. Shift number. Let's just give it whatever. I will give it 23. Let me give it too crazy number. Let me just give it 8. Then you can see the encoded test is. You can see changes everything. Type yes to restart or no to end. And I can say yes to restart, and the program is restarting. Then type encode to encrypt or decode. Then I can say decode. Let's decode, and I can give it. So then type the shift number. We use 8, so let's use it again. See, we get the same thing back. November 97. So it's working well. You can check. You can go again and again and check. I say decode. Let me say okay. Let me just give anything and see what happens. Invalid input, and it start again. Type encode. You can see. So even if you type whatever, is catching it. Invalid input type. Give encode now. Then type the test to encrypt or decrypt. Then I can let's give whatever we want, and I can say 2134 like that. and shift number I can say 15, or let me give something that is not a number here, and he said type a number please, type the shift number. You can see that, so it's really working as we expect it to work. Then let me give 15 now, give 15, then you can see this is our encoded. And if I want to run it again, I'll say yes. Let me decode it now. The program is restarting. Then I'll say decode. Then I'll say okay. So let me give the value, the encoded value back. So let me give it. Then the shift number we used was 15. You cannot forget your shift number, or else you get something else. Shift number, and we'll get the same thing back. You can see it's the same thing that we use, mountain, this like that. So that's that. And if I get no, and the program end, goodbye. All right, so I hope you benefit a little bit from this video. Try it yourself. Use the 80-20 rule. 80% of the time, make sure you are coding and you're practicing your skill, and 20% of time you can use it to watch videos, tutorials, and whatever else you want to do. But most of the time, make sure that you are writing your code so that you can improve your skill. All right, thank you for watching this video. I will see you in the next video. Bye bye for now.